So the question that we need to ask as people studying thermodynamics is, will this work? We've come up with this great new idea. We want to be able to recover a lot of energy out of our fireplace. So let's say I came to you with this idea. You're studying to become engineers. You should have the tools and be able to solve this. So as engineers, you should be able to figure this out. And that is, figure out, will it work? Well, when we think about it, what tools do we have thus far in your education? So tools, and that would be courses that you may have taken. And so perhaps you've taken a course in fluid mechanics. Where would you use fluid mechanics here? Well, you have to pump in the air for that preheat air system. So you could use fluid mechanics for the design of the preheat air system. What kind of calculations might you use there? Well, you have to know how to size the blower. By that we mean what kind of pressure rise will the blower generate, and that pressure rise would have to equal the pressure drop that you'd have going through that heat exchanger. So with fluid mechanics, you may be doing things like determining pressure drops in lines, because remember there were other lines that we had for sending the fluid through the turbine. So pressure, determine pressure drops in lines. And size the air blower. Okay, so that's one area that you might have knowledge. Another one, and I did mention this a few times, talking about the design of the new fireplace, heat transfer. As mechanical engineers, you will study heat transfer. And heat transfer is used quite extensively throughout mechanical engineering thermodynamics. We don't get into the same detail as you would in a heat transfer course. However, you would need heat transfer to compute a lot of the things that you use in mechanical engineering thermodynamics. So this would be for the design, and quite often in heat transfer that translates into sizing. So it's sizing and the design of all of the heat exchangers. What other things may you need? Well, maybe you need a first course in thermodynamics, because we're going to jump into it here, but you would want an introduction to things like the properties of gases and liquids that we'd be using, the first law, the second law, and consequently you would need to have some experience in thermodynamics. And what would that give you? Well, you might be able to do a preliminary design, and you might look at efficiency considerations. So with that, you may find that your design is not as efficient as it could be. Maybe you have to operate at a higher pressure, With that, you need a different pump and different lines, things like that. Now, what about subject areas that perhaps we're missing? Well, we're missing this course, the one that we're now teaching. We're missing what I will call thermodynamics 2. So this would be mechanical engineering thermodynamics, the study of cycles. And in this course, what we're going to be doing is a more detailed analysis of cycles. And we'll look at a bunch of different cycles, but the one in particular here would be the vapor power cycle or the steam cycle, sometimes also called the Rankine cycle. And the other thing is we'd have to look at combustion. Remember, we were preheating the air. Turbomachinery. This is another subject area where if you're designing either your pump or your expander, the turbine. Okay, so those are a couple of areas. Another course that you may want is gas dynamics. Depending upon the nature of the flow that you have with the superheated steam, and this is what we refer to as being compressible flow. So those are some of the other courses that you may need in order to design this type of a system. So if we really wanted to do this design and figure out whether or not it's going to work, we're going to need to do a detailed thermal fluid analysis. And this would combine all of the subject areas that I just talked about.